Okay, so the first question we're going to go through is question 1. Question 1 talked about the cube root of 64 times 1,000. So there's two ways of answering this question, and there's the easy way and the hard way. I think the harder way is to do 64 times 1,000, which we know is 64,000, and then do the cube root of that. And think which number multiplies itself 3 times to make 64,000. Now, if we think of cube roots, we know the cube root of 64 is 4. Okay, so we know it's got to be 4 something, and our answers are 40, 80, 400, and 4,000. So we could just check them, which ones work. And the only one that works is 40, because 40 times 40 times 40, 4 times 4 times 4 is 64, 1, 2, 3 zeros. Okay? Now, there is an easier way of thinking about this, which links to all your favorite topic, which is surds. Okay? Because surds say that I can break this apart and do the cube root of 64 times the cube root of 1,000. So normally surds we deal with square roots, but surds also work with cube roots as well. So the cube root of 64 is 8, cube root of 1,000 is 10. Sorry, cube root of 64 is 4. First mistake of the video. Should we keep a tally of this? 4 times 10 is 40. Okay? Hang on. Stupid mistakes. 1. All right. Every time you see 1, catch me, and I'll keep that tally. And at the end of the video, we'll laugh at how stupid I've been. Okay. Question 2. Question 2 talks about column vector stuff. Column vectors we've come back to recently, so maybe this is easier. So the vector -2, 3 gets you A to B. And then what it wants to know is what gets you from B back to A. So what's the reverse of -2, 3? So this means 2 to the left, 3 up. So to reverse that and go the opposite direction, I've got to go 2 to the right and 3 down. So the answer is 2, -3. Okay? We're skipping question 3 because most people got that right. Question 4. So this is an estimation question. And question 4 says, circle the number that's closest to 9.8 over 0.0195. So this is basically estimation. So when we're estimating, we round everything to one significant figure. Okay? What does 9.8 round to one significant figure? 10. And what does 0.0195 round to one significant figure? 0.02. Okay. So that's my estimation. This division is not an easy division to do, but I can use fraction ideas to make this an easy division to think about. So all I need to do is use equivalent fractions to make the denominator a whole number. So if I times this by 100 and times this by 100, I end up with 1,000 over 2, which is 500. Okay? Whenever you've got division, especially on the non-calculator paper like this, whenever you've got division and the thing you're dividing by is a decimal, use equivalent fractions to get rid of the decimal and then do a whole number division. Question? Go on.
Well, this doesn't, when you times it by 100.
No, because I've times the numerator and the denominator by 100. So because I times both the numerator and the denominator, it's kept it as an equivalent fraction, which is exactly the same thing. Okay? So I can do this with anything. Just think, for example, we all know 10 divided by 2 is 5, don't we? If I times the top and the bottom by, for example, 4, 40 divided by 8 is also 5. Yeah? And 400 over 80 is also 5. All of these things have the same answer, which is why this trick is really nice to use. Okay, question 5. I think the biggest mistake here was just forgetting the little trick around inequalities. So this was a nice, easy inequality question, but a lot of people wrote the answer x equals 9 when you need to keep that inequality symbol in the answer. So we expand our brackets, subtract 15, divide by 5, and the answer is x less than 9. Do not put an equal sign there. Okay, question 6. So what we just went through on question 4 is actually helpful on question 6. Question 6, the height of Zach is 1.68. So Zach is 1.86, sorry. And Fred is 1.6. Second mistake, thank you. Right, Fred is 1.6. Write the height of Zach as a fraction of the height of Fred. So that means do Zach over Fred. Okay? So then I do 1.86 over 1.6. It says give your answer in simplest form. So we need to multiply this by 100. 186 over 160. And then cancel it down. So that becomes 93 over 80. And then we've got to check, does this divide by anything else? So the only things 80 divide by is multiples of 2 and 5. 93 doesn't divide by either of those, so that's my simplest form. Okay? It's actually quite an easy question. Questions 7 and 8 we are skipping because we did quite well with those. I was really impressed with question 7, by the way, because question 7 is a bit of an awkward one, yet most people managed to get that. All right, question 9. Okay, question 9. The range is 15 1/4. The smallest is -2 7/8. Work out the largest number. Okay, so let's think about what normally happens. This question's weird because there's fractions involved as well as the word range. Let's just think for a second how we would do it if it was whole numbers. Okay, so if they gave me whole numbers, I know that the range is biggest, take away smallest. If I've been given the range and I've been given the smallest, how do I work backwards to make the biggest? I add the range and the smallest number. So the biggest number is the range plus the smallest number. So I need to add these two things together. So I've got 15 1/4 plus -2 7/8. This bit here looks odd, but we know how to deal with that. We replace that plus minus bit with just a minus. So I get 15 1/4 take away 2 7/8. And then I've got to do mixed fraction work. So 15 times 4 is 60, add the 1, 61 over 4. Take away 16, 23 over 8. Make the denominators the same, so double this one. 122 over 4. Take away 23 over 8. That doesn't even look like a 3 anymore. Well, no, that's too far. Okay, so 122 over 8, take away 23 over 8, which gets me 99 over 8. Okay, it asks me what the largest number is. I can leave it. It doesn't